Hey, please don't try anything you are about to see at home. I'm your core nukers. Oh, just kidding. Hello all, my name is Siming Qin and I'm a prospective senior student at Department of Nuclear Engineering and Radiological Science. It's my great honor to work with Professor Gary Wars in my department at Michigan Iron Laboratory during this summer. Established in October of 1986, the lab has created a wonderful research realm for advancing our understanding of iron-solid interactions by providing unique and extensive facilities to support both research and development in the field. Since MIBO is under construction these days due to the coming of some new facilities, there's lots of work, both mechanical and electronic. Based on these two aspects, I have been working on 4 projects as following. As for the mechanical part, by using Autodesk Inventor, I have been designing a shielding support for frame. As we all know, when doing something radioactive, we should be really careful about how we can handle it. In MIBO, high radiation dose is inevitable. Thus, shielding is very crucial. After running simulations with MCMP, a software that simulates neutron reaction with other surrounding stuff, the supporting frame was designed to be stable and movable for holding 8-inch thick bolted polyethylene board and several inch thick lead sheet on the top of that. And as you see here, this is the beam stand and this is the shielding support frame. When the beam comes in this direction, and it will be shielded by the bolted polyethylene board and with some lead shield around, and the joint component looks like it should be worth it, and the actual mechanic job will begin soon. Another project is to design our own MIBO cooling system using Inventor 2, creating extreme saturation to run experiments. Overheating is also a headache for the equipment. Cooling system is therefore very important to prevent our facility from having a fever. Considering of the limited space inside our lab, the system should be both efficient and small size. With the help of Inventor, MIBO cooling system can be created by using the 3D assembly model inside the Inventor. As you see here, this is our MIBO cooling box and it looks like that. This is a 3-gallon tank contains all our cooling fluid, and the cooling fluid will run through this pipe, come to the pump, and the pump will pump it through the cooling furnace, and continuously the fluid will go outside, cool what it should cool, and run back from the hole here back to the tank. And to be movable, there's 4 walls on the back, on downward, and in the front we also create a front panel that with switch control and power, some LED control and power plug and fuse there to make us can control all the cooling box. For the electronic stuff, a database has been created by using LabVIEW. I think while I mentioned database, a lot of people may think, why don't you use SQL or MySQL? The reason why I choose LabVIEW is because LabVIEW is a very common used software in our lab, and this choice can avoid some difficulties and problems dealing with data transformation from one port to another. And what's more, LabVIEW has a very powerful file import and output tool called TDMX function. By using those VI's built-in TDMX function inside the LabVIEW, you can achieve the same goal as well as using MySQL, or even better. To say if we have 1000 data points in one row, and we're gonna update those variables per second for 1 day. And for now, we simulate a data file that contains 0.11 and repeat that for 1000 times to represent, we have 1000 columns, and using the TDMS, actually the advanced TDMS function to simulate that. After running the program, it will come up a TDMS viewer, and from the data channel will from 1 to 999. That's 1000 columns and 1000 channels. And you can see here each channel length is 86,400, and it has the value from the top to the end. It's all 0.11. Last but not least, I have developed a user interface for choosing regions of interest on a thermal camera image by using LabVIEW 2. Dealing with material under high temperature and high radiation dose, analysis of the thermal image will be very helpful to understand how and why the material properties will change like that. And now you see this is the user interface for the thermal camera image, and on the left hand side, now it's a live picture for water bottle filled with hot water, and you can see my hands moving. And first we can choose on our eyes regions of interest stands for, and now by holding the control button we can choose several of these, as many as we want, and after that we can assign emissivity to it. And now you see the rays keeping updating on the right hand side, but rather than just choosing ROI then assign emissivity, what we can do is we assign emissivity first, then choose ROI. That way it works fine. And now you see we assign 0.8, 0.3, and we can choose ROI 5, ROI 6 to it. And you can see the emissivity, the temperature, the mean, the standard deviation, the minimum, the maximum value, or the values for the ROI we choose to show there. And we can change the temperature unit too. For Kelvin, for degrees Celsius, for Fahrenheit, there are different temperature according to the different type of unit we choose. The array will keep updating as we want. And now you see we can assign as many as ROIs as we want. And also if you type wrong emissivity, if you want to change that, that's fine. Now you see after typing the new value and hit enter, the value will keep updating as we want. And that's it.